Welcome to LEPAK Chapter 3. Let's try to discuss question 1a. So calculate the resistance of a 5 meter long aluminum wire with a diameter of 1 millimeter. The resistivity of aluminum at temperature of 20 degrees Celsius is 2.8 times 10 to the power of negative 8 ohm meter. Okay, so they ask you to calculate resistance, but this particular conductor here has it's a 5 meter long aluminum wire. So they tell you that this wire is made of aluminum, it is 5 meter long, and it has a diameter of 1 millimeter. When we say diameter here, it means that if this is a wire, if you look at its cross-sectional area, then the cross-sectional area will be a circle, then the circle will have a diameter of 1 millimeter. Okay, then since they tell you that this wire is made of aluminum, they also tell you that the resistivity of aluminum at the temperature of 20 degrees should have a Celsius here. It's 2.8 times 10 to the power negative 8 ohm meter. So let's try to make a bit of modification. Let's add on a C behind. Okay, so let's try to visualize the situation here. We have drawn here a piece of aluminum wire. So some important information we know from the question is that this aluminum wire here has a length of 5 meter. So you can label this as L is equals to 5 meter. And you also know that the cross-section area has a diameter of 1 millimeter. So the diameter will be in D. So it will be 1 times 10 to the power negative 3 meter. Then lastly, since they tell that this wire is made of aluminum, so the aluminum will have its own resistivity. And for temperature of 20 degrees Celsius, the resistivity of aluminum is 2.8 times 10 to the power negative 8 ohm meter. Okay, so you have all the information you need actually to determine the resistance of this aluminum wire over here. And the equation to determine resistance is R is equals to rho L over A. Okay, so probably in your syllabus you are introduced to it in different way. You're introduced to it in this way. Okay, if you are expressing your equation in this form of equation here actually try to define resistivity. So I'm defining resistivity here as the resistance of 1 meter square cross-sectional area of conductor with length of 1 meter. So if you want to determine the resistivity of a material, what you do is you take that material, shape it into something with 1 meter square cross-sectional area and 1 meter length. If you shape your conductor in that way, 1 meter square cross-sectional area, 1 meter length, and you determine its resistance using Ohm's law maybe, then that resistance you obtain will be equals to the resistivity of that material that made out the conductor. Because you substitute 1 meter square over here, you substitute 1 meter over here, then the resistivity of the material will just be equals to the resistance of that conductor that you shape it in 1 meter square cross-section area, 1 meter length. Okay, but if I rearrange it into this form, this is a form that is more commonly used in international books. So this form of equation here is trying to say that the resistance of a conductor depends on 3 different factors. The first factors will be the resistance of the material. If the material has higher resistivity, it will cause the conductor to have greater resistance. It is also dependent on the length of the conductor. You have a greater length of conductor, you need to pass through more positive ions in order to get through the material. So you have greater resistance. Cross-section area, you have greater cross-section area, you have more space to pass through the material. So you have lower resistance. So these 3 factors over here contributes to the resistance of an conductor. Okay, they are just rearrangement, but the way to interpret it can be a little bit different. Okay, so now we have all the values we need actually. You have the resistivity, you have the length, and you know that the diameter here can allow you to find the cross-section area. So what you need to do right now is to re-express the cross-section area in terms of diameter. So you know that this is the resistivity of aluminum times the length, and you know that the cross-section area for a circle is just pi r squared, but since you don't have the radius, you know that radius is just half of diameter. So now you have already change your equation, replace the cross-section area with pi d over 2 squared. So now it's just a matter of substitution. So you substitute in the resistivity to be 2.8 times 10 to the power of negative 8. Substitute the length to be 5 meter. Divide by pi. Then the diameter is just 1 times 10 to the power of negative 3. Divide by 2 squared. Okay, so if you use your calculator to do your calculation, I believe you'll get an answer of 0.18 ohm. So that's it. This 0.18 ohm represents the resistance of this particular aluminum wire over here. If you change the length, you change the resistance. If you change the cross-section area, you change the resistance. But if you change the material, then you change the resistivity. But for now, for this particular aluminum wire, this is the resistance of the wire. Okay, so that's how you solve question 1a.